Hi, welcome to Humber's Numbers. I'm Rose Humberstone. In today's video, we're going to look at Area of Study 1 from Mathematical Methods, Functions and Graphs, and we'll be focusing on some graphs and their key features. In particular, we'll look at what a function is, types of functions, some key types of graphs, and some important things to know when graphing. Finally, we'll look at some sample VCAA questions, which covers these points. Okay, so let's start with functions. A function is a relation or a set of ordered pairs such that each element of the domain has only one corresponding element in the range. And that's quite a mouthful. So let's look at each of these words independently. So first of all, a relation. A relation is just what it says in the brackets. It's a set of ordered pairs. That is, we're looking at pairs x and y values, and we've got a set of them, so we've got multiple of these pairs. The first element, the x, tells us our domain. So if we look at all the different x's, then we know all the different values that our function applies to. The y values, or the corresponding element, gives us our range. So a function is a set of pairs where the x and the y give us our domain and range, and importantly, each element of the domain, so each x value, has only one corresponding y value. So we've got two examples here of function notation. Our f and g tell us the name of our function. Then what we have is we have our domain. In the first case it's r, and in the second case it's all of the real numbers except for 2. The next thing causes some confusion. This is actually the codomain, not the range. The codomain is a set that contains the range, so it can be larger than the range is. Then what we have is the rule. This tells us how the x and the y value relate to each other. Alright, so let's look at some types of functions. One-to-one functions. A one-to-one function is such that different x values map to different y values. It passes both the vertical line test, where a vertical line intersects at most in one place, and it also passes a horizontal line test. Again, it intersects in only one place. In contrast, some functions, like this parabola, are not one-to-one, because a horizontal line intersects in two places. Note that this is a function, but it's just not one-to-one. Okay, what about odd functions? The definition of an odd function is that if I apply the function f to negative x, then I get the same value as negative f of x. So if here is my x and here is my negative x, then I'm going to have f of negative x here, and here I would have f of x. So that is, these are the negatives of each other. From a graphical point of view, we can think about this as a rotation of 180 degrees about the origin. An even function is one where f of negative x is equal to f of x. So x here and negative x here, they have the same y value. That is, f of negative x is equal to f of x. They're the same. This here is a reflection in the y-axis. Now, as you can see, most functions that we look at aren't odd or even, but it's important that you know the definition of each of these. Okay, let's start by looking at some key types of graphs. Now, in this video, we're just going to be focusing on polynomials, so linear, quadratic, and cubics. There's another video that focuses on other types of graphs listed here. So key types of polynomials are our linear graphs, our quadratics, giving us parabolas, and our cubics. These three are just the basic ones. So our first one has a gradient of 1 and goes through the origin. Our second one is a simple y equals x squared. And our third one is a simple y equals x cubed. There are many ways that these can be transformed, which again we'll consider in another video. When you're graphing, you must include intercepts as coordinates, stationary points as coordinates, and intersection points as coordinates, and you should also sketch your graph in one line. Now, if you're doing past exam questions, you'll notice that in earlier exam papers, they didn't say to give it as coordinates. However, in later ones they have. You should always give in coordinates, regardless of whether they say to or not. It's simply good practice. Okay, let's look at some sample VCAA questions. Our first question comes from the 2015 Exam 1 paper, and it's question 4b. We're given a function f with a domain of -3 to 2 and a codomain of r, and the function is f of x equals a half bracket x cubed plus 3x squared minus 4. There's a part A to the question, which asks us to find stationary points, which is not the focus of our video. And then in part B, we're asked to graph f, clearly indicating axis intercepts and turning points, and then to label endpoints with coordinates. So notice here that the axis intercepts and turning points are not explicitly mentioned to be given as coordinates, but we will. All right, so let's see what we need to include here. So from part A of the question, we're going to have some stationary points. So I'm going to tell you what those are. They are at -2, 0, and 0, -2. So that will be here and here. All right, our x-intercepts. Well, we can get those straight off by using the null factor law. I'm going to have it at x equals 1 and x equals -2. Next, my y-intercept is going to be, looking here, it's -4 divided by 2, so -2. And then I also need to consider my end points. So f of -3, substituting -3 in for x, I get -2, and f of 2, I get 8. Okay, so let's get those points here in. So x-intercept here. At -2, I've got an x-intercept. Notice that because that point is squared, it's going to be touching. So it's going to touch there. My y-intercept is at -2, and I have endpoints at -3, -2, and at 2, 8. So now what I need to do is very carefully sketch the graph, ideally in one line. I would recommend you sketch your graphs in pencil. Like so. Now we label. And there you have it. So do make sure that you label your endpoints with coordinates. Make sure that you go through all the key points, it's like turning points, and that you've got your x and y intercepts given. It's often a good idea to, once you've done your graph, to go through, read the question again and tick off. Have I got my axis intercepts? Yes. Have I got my turning points? Yes. Have I got my endpoints? Yes. Notice that that was a pretty easy question, really. It was worth 2 marks, but only 54% of the state got the question correct. Our next question is from the 2013 Exam 1. Now this is question 9A. So 50% of students got this correct, and it's unclear whether that's because they found it difficult or perhaps because they didn't even get up to it. The question asks us to essentially find the x-intercept, or the value of a here. What's important to note in this question is that there's a restriction on the domain. X comes from -2 to 2. That is, the graph doesn't just keep going here. All right, so let's find that value of a. We are simply going to be solving 0 equals x minus 1 squared minus 2 for x. So adding 2 to both sides, taking the square root of both sides, remember the plus and minus, and then adding 1. Now, it's always good practice to have your variable on the left-hand side, so x equals 1 plus or minus root 2. Now, notice that if there was no restriction on the domain, there would be two x-intercepts, one here and one over at a. This one that's actually not there is going to be our 1 plus root 2. So therefore, a is going to be equal to 1 minus root 2, which of course is negative. So that's our answer. Now, a lot of students who did attempt this question actually had the positive answer, which is obviously incorrect. Next up, we have the 2015 Exam 2 Multiple Choice Question 3. Now, this is a really classic type of question. We've been asked to find the rule for a function with the graph above. Now, there are many possible rules because we're not told what the y-intercept is. So we're just going to be using the information that we have. Okay, so the first thing we notice is that here we have an x-intercept at d. So that tells us we're going to have an x minus d in our rule. We then have an x-intercept at c, and at this point the graph is touching the x-axis. So that is, we're going to write this as x minus c squared, since it's touching. Now here's the tricky bit. We have an intercept here at b. Notice that b is a negative number. So that is, we're going to have x minus b, not plus b. Lastly, notice that the graph is finishing negative. That means that our number out the front, our a, is negative. So looking at our options, we need x minus b, x minus c squared, and x minus d. So that means our answer is going to be C. Now, only 20% of students got that correct, which basically is the same as people guessing. Now, as I said, this is a really standard type of question, and there have been many similar questions in the past. So do make sure you understand it. Well, that's all for today. If you've got any questions, then obviously you can comment or you can rewatch the video. I hope you join me for the next video on functions and graphs, other graphs, and combining functions.